We are going to have a fun session today. Lots of stuff to talk about here. This is kind of an interesting presentation in that this particular presentation doesn't map directly to one specific certification exam, for example. It's broadly applicable, however, to several. And so we'll talk about that in just a few moments. But it's kind of a topical discussion, and the focus is on security in Windows networks. And so kind of an overview of the fundamentals of security in the Windows environment, the Active Directory, Azure AD environment. So what we're going to be covering here is, as I say, very broad. We're going to talk about on-premises Active Directory networks. We're going to talk about cloud-based organizations, Azure AD, organizations with a hybrid model where you have, and that's really most of them these days, where you have a combination of on-premises Active Directory networks and cloud-based users as well, using Microsoft 365, Office 365, and so forth. So we're going to be talking about relevant Microsoft security technologies in those environments. Now, one of the big things we're going to be doing today is just understanding what Microsoft means by its brand names and its terms for its different security-related technologies, and there's a bunch of them. So sometimes it seems like 90% of the battle is just understanding what all the words mean and all the acronyms and so forth. And to keep things interesting for us, Microsoft keeps changing them. So a given feature will have one name today, and it will have a different name 6 months from now. I also, one of my goals for today is to help you reach the place where you understand when each tool is appropriate. We are going to cover a lot of different tools from Microsoft. They've been in the software business for a long time. They've developed a lot of tools. So we have a very, very large toolbox. And so it can be a little bit confusing to know when should we use this versus that. So we'll be sort of focusing on that as well today. So delighted to be here with you. I got tired when Nurul mentioned that I'd written 18 books. I thought, God, my gosh, has it been that many? I got out of that business a few years ago when I realized that it was kind of a dumb business to be in, because in our world, right, in the IT world, things change so quickly that you can write a book and in a few months it's out of date. And so not a great business model. My book agent used to say that writing computer books was a slow way to get rich quick. Ultimately, I learned that, but it took me a long time to get there. So now we're doing presentations like this and video courses and things that you can change easily, and that's a smarter model for imparting information to those of you who are hungry for it. All right. Well, so this is a view from 30,000 feet today, forests rather than trees. One of the things that although we're focused on security, one of the things we're not going to talk about very much, if at all really today, is disaster recovery. If you're interested in that, that could be a separate topic that might be actually kind of a cool thing to do in a session like this, disaster recovery in Windows networks. But we're not really going to get into disaster recovery much. So that is, however, an important aspect of IT security. And so I don't want to imply that it's not important. We just only have 3 hours, and there's only so much that we can cover. The intended audience for our session today, really IT admin types, either present administrators or hopeful upcoming administrators who need to deal with security issues. And that's just about every IT administrator. You might be a support tech needing a grounding in security. You might be a developer who wants to understand the security context for the apps that you're working on. Or you may be interested in acquiring a certification that requires an understanding of security. And so some of the ones that do have some relevance to this session, I'm going to discuss here on the next slide. So you might have some security background, some of you, but might be new to the Microsoft networking world. And so there are all these different tools and apps and consoles and capabilities. And so you might want to know what the lingo means. And so that will be a good goal here. So one of the things that I'd like to do here today is sort of help you identify some gaps. Okay, so sometimes for me, when I attend sessions like this, and I try to do that as often as I can, the main benefit that I'll get out of it is learning what I don't know. Say, oh, okay, so here the presenter is talking about X, Y, and Z. I don't really have a good background in those topics. that's some stuff that I need to do some online research or video training, or get some books, or what have you. So gap filling would be a good way to look at this session today as well. So some of the certifications that this session is going to be relevant to. So we have the Security Administrator Associate in the Microsoft 365 Certified designation. There's also the Azure Administrator Associate, the Modern Desktop Administrator Associate, the MD100 and MD101 exams. So various different exams, and there are others as well. I mean, beyond the Microsoft world, of course, in the CompTIA world, we have A+, we have Security Plus. Certainly, this information would be very helpful for those of you who are pursuing some of those CompTIA certifications as well as these Microsoft certifications. But it doesn't map exactly to any of these, but it's great background for these IT admin type certifications if any of you are pursuing this. Okay, so some of the things I just sort of like to throw out there at the beginning, and you can take your time and just post some answers in the Q&A widget. But I'm kind of curious, what you're looking to get out of this 3-hour session here. Are you in IT admin? Are you in app development? Are you in tech support, desktop support, and so forth? And do you see this security topic as a way to advance your career? So if you have any thoughts on that, you want to put them out there. I'm going to try to keep an eye on the Q&A as we go along. I will try to focus on it during our breaks. And my goal is to try to answer all of your questions. I don't always fulfill that, but I'm going to do my best, allowing for me to have at least 3 minutes at the break to go grab a refill for my coffee cup. But I'm going to try to answer those questions, but it won't be instantaneous. It'll be asynchronous. So our subjects today, with approximate times for each of these. So we've got 7 topics: operating systems hardening, application hardening, credential protection, data protection, communications protection, and then anti-malware. And we'll wrap up with a short section on auditing. So those are the broad areas that we're going to be covering. And so without further ado, let's dig in, because we've got a lot of stuff to talk about. So we better get started. Operating system hardening. All right, so improving platform security. So what do we mean by this? Well, it's a matter of increasing the out-of-the-box security, if you want to think of it that way. So you install an operating system, brand new, fresh, and is it secure enough for our purposes? And usually the answer is no. Now, in the Microsoft world, it's gotten better. So I cut my teeth back in the day. Well, I won't tell you how far back I go, but it's even before there was a Windows. But during the early years of the Windows evolution, Microsoft was really focused on compatibility, making sure that Windows worked with everything, and they were not too concerned with security. Even Windows NT had some issues. That was the more secure of the two platforms. You had Windows 95, 98, and you had Windows NT. NT considered the more secure one. But even Windows NT was not really as secure as we might like out of the box. So even today, Microsoft has changed its orientation. The default configurations when you install Server 2016, Server 2019, even, well, to a somewhat lesser degree, Windows 10 and Windows 11. But when you install one of the Microsoft operating systems today, it's more secure out of the box than it used to be, because they've changed their philosophy. But there's a lot that we can do to make it better. And our world is so dangerous that we need to. So our topics here in operating system hardening: Windows updates, group policy and security baselines, Azure AD, and then Intune, which is Microsoft's mobile device management platform. And then some operating system isolation capabilities for specific circumstances. We'll talk a little bit about virtual desktop infrastructure there, and something somewhat new called the Windows Sandbox. All right, so updates. And this is not a guarantee that you'll never have a security problem in terms of malware, for example, but it certainly improves your odds. And Microsoft's got lots and lots of people working on Windows updates. And so the thing we have to deal with as admins or prospective admins is that our window of time, no pun intended, well, it was intended, is very, very narrow these days. That is the time between when a vulnerability is publicized or published and when it is exploited by the bad guys. That window of time is very, very small. In fact, there's a whole category of malware called zero-day attacks, where we talk about things that are just brand new and we didn't even know about them before. And so our tools that are relevant here, WSUS has been around for quite a while. It's still around, now a part of Windows Server. It's a Windows Server update service. Microsoft Intune can manage our updates for cloud-based devices. That is now part, it used to be part of the Azure portal. Intune is now part of the Microsoft Endpoint Manager portal. Endpoint Manager is their new name for what we used to call SMS and System Center Configuration Manager, now Microsoft Endpoint Manager. So that's the big enterprise scale Microsoft configuration management tool, right? So these are the tools. And then Configuration Manager is kind of our, the old version of that, which still a lot of people are using. So WSUS, and thank you, by the way, for the comments on the inbox, and we got some experienced folks out there, which is great. Again, for those of you that are experienced, you're going to see some things that you already know, but you might see a few things that you'll say, okay, that's an area I didn't know about. Let me focus on that and do some gap filling. So WSUS has been around for quite some time. It used to be a separate download. Now it's part, as I say, it's a role in Windows Server. And it allows us to create groups, and these are sort of unique to this WSUS world, but we can create different groups and deploy Windows updates to those groups. So we don't have to necessarily deploy updates to everybody at the same time. Certain types of updates we might want to deploy to everybody at the same time. For example, Windows Defender antivirus updates. So for that, you see the third bullet here, we could do automatic approval rules. So we want, initially, the thought was, oh, we'll have IT administrators look at every single Windows update and test it and maybe push it out to a little pilot group, which might be the IT support organization. And then, once we have determined that there are no conflicts and it's fine, then we can release it broadly. Well, we don't have time for that anymore, right? We don't have time to test every single update. But we can, for certain types of updates that we trust, that we generally don't have problems with, such as the Defender antivirus signature tables, we can just create auto approval rules for those. We can also do, the second bullet here talks about something called client-side targeting, which is kind of interesting. That allows us to, again, automate this process a little bit. The more automatic we can make things, the more automatic we can make security in the environment, the better. So with client-side targeting, we have organizational units in Active Directory, kind of an organizing structure here. And we can set it up so that when we add a PC to an organizational unit, it automatically gets added to a WSUS deployment group. So we don't have to explicitly manage these WSUS groups separately in a completely manual manner. Okay, so bullet 4, we have the ability with this console to monitor successes and failures. Now, this is actually kind of a big deal, because if you've got any experience at all managing Windows and Windows updates, you've seen Windows updates that fail. And the problem is actually getting worse, at least what I hear from my students and my clients that are doing this every day, because some of these updates have gotten just huge. The so-called cumulative updates have gotten very, very large. And so if there are glitches in the download, whatever your source is, Microsoft or a WSUS server or what have you, then those updates can fail. So it's very important that we understand, hey, here's an update, here are 20 systems on which it has failed, and then we've got to address that, right? So we can't just presume that these automatic updates are going to work perfectly, because they often fail. Now with WSUS, we can have autonomous versus replica servers. And what that means is you can have multiple WSUS servers in an organization. So you can have geographically dispersed update servers. And these guys are going to talk to Microsoft and get the updates. And then an administrator will bless them, approve them, and then release them for deployment to these individual groups that we talked about. So it's a staging process, really, just to make sure that for things that we want to check, for big cumulative updates, we may want to do some testing. And then we can devise some rings, some deployment rings of kind of early adopters, and then middle of the road, and then everybody. Well, if we have a big organization spread out geographically, we may need multiple WSUS servers for performance reasons. We can set those up to be autonomous, in which case each WSUS server manager will manage them independently, set policies, even create different groups and so forth. Or we can connect them and say that this is a replica of another WSUS server. If you want to just have all the management, all the decisions made at one place, maybe a parent WSUS server, and then you have a number of child WSUS servers that are replicas that will get their policies from that one main system. So we get to decide how we want to do it, decentralized or centralized type management. We can also configure these, very interestingly, based on bandwidth issues, in terms of where the updates are going to come from. So if we have, for example, a very good internet connection, but a crummy WAN connection to a parent WSUS server, we might use the WSUS server for policies, but actually have clients get their updates from the public internet. Also, delivery optimization is a kind of a mildly new capability whereby Windows clients can get updates from each other, right, from their peers. So that is something that can relieve some of the load on those central update servers. And it can be very useful. You just have to be a little bit careful. There are two settings there. Do you want to get updates from your peers on the LAN? And then do you want to get updates from the public internet? And that latter one is something that maybe is not the greatest idea for some organizations. All right, so that's WSUS for kind of an on-premises environment, but what about for a cloud-based environment? Well, we've got Intune. Microsoft Intune is the MDM, the mobile device management solution. It's also got some mobile application management capabilities as well. Now, it is what we're going to use to manage cloud first and cloud mostly, right? Cloud mainly devices, cloud first and cloud only. It's going to leverage groups that we set up in Azure AD, which is the identity store for Microsoft 365, as most of you probably know. Again, in Intune, it's a completely different setup than WSUS, but again, we do have some of the same capabilities. Auto approval rules, monitoring of update successes and failures, and delivery optimization are all available to us in the policies that we can create in Intune. But just kind of remember that Intune is going to leverage those Azure AD groups. You don't have special Intune groups, right? It's just going to use existing groups or new ones that you create using Azure AD. And you can create those in the Azure portal. You can create those in the Microsoft 365 administrative portal. Wherever you create them, Intune can use them. And we can set up these different rings. And so we also have Configuration Manager, another on-premises tool, now Microsoft Endpoint Configuration Manager, formerly System Center Configuration Manager. It actually uses WSUS. So some of the terminology changes, right? We talk about an update point instead of a WSUS server, but the concepts are the same. Microsoft said, why reinvent the wheel? Let's just use the WSUS engine. So that's what's actually running behind the scenes if you happen to be using Configuration Manager. All right, so these are some things that we can do in order to make sure that our systems are updated, and that is a huge step to improving security, rapid updates and automatic updates. So the more automated we can make that process, the better. Now, another very important thing that we can do here is we can create baselines. So we can create these baselines that are going to be useful in deploying configuration changes. So for operating system hardening, updates is one thing, and that's great, very important to do it. But we also want to make sure that all of our systems are going to be configured in a way that is secure enough for our purposes, right? And so how do we do that? Well, group policies is kind of the traditional way to do that. Oh, and by the way, a question came in, can WSUS be harnessed to roll out custom application updates? WSUS is really focused on Microsoft updates. However, within Intune, we can deploy updates for applications. There are some hoops you have to jump through to do it. But WSUS can deliver application updates for certain Microsoft applications, right? Office 365, for example, it can handle that. But in terms of just generally doing updates for third-party applications, it's really not set up for that. But you can in Intune. So that might be an advantage to look at Intune versus WSUS if you have a lot of third-party products. But for just Microsoft products, like Office, then yes, WSUS can handle those updates. So the concept of baselines, very, very important concept. What we'll do is we'll take a look at all the gazillion settings that a Windows device has. And that's one of the challenges, right? We have so many different settings. How on earth are we going to wrap our brains around them and think what's appropriate for our environment? What do we need in order to harden the operating system? Well, thankfully, we have some tools that are going to help. Group policy to start with allows us to push out configuration changes to sites, to domains, to organizational units. And then we have something called security group filtering, third bullet here on the slide, that allows us to narrow that further and say, well, there's only particular groups, Windows groups, that we want this group policy to apply to. And then we can do more fine-grained filtering through something called WMI filtering, Windows Management Instrumentation. But mainly, when you think of group policy, you think, well, let's do this per domain or per organizational unit or per Active Directory site, which is usually a geographical boundary. Now, the problem is there are something like 4,000 group policy settings at this point. Okay, I mean, it's just nuts. I've been teaching group policy for years, and it just gets more complicated every time there's a new release of Windows because we have more group policy settings. So really, when something's in the thousands, we need some help. So there are some tools now, the specialized GPO tools. One was recently retired a couple of years ago. That's the SCM, the Security Compliance Manager, which actually I thought was great, but they retired it and they replaced it with something that is also great called the Security Compliance Toolkit. And they're keeping that up to date, actually. I mean, they've already got a Windows 11 baseline. I had to laugh at the Windows 11 announcement because several years ago when Windows 10 came out, Microsoft said, this is it. Windows 10, no more versions. We're just going to do twice annual updates, and this is the last version of Windows that we'll ever have. It's Windows 10 forever. And I thought to myself, nah, there's no way they're going to stick to that. And now we know that they have not. And now it's Windows 11, and we've got to throw out a lot of our old systems because of the processor requirements. But that's another rant for another time. So the Security Compliance Toolkit, free download, updated, and gives you recommended Microsoft baselines for lots of different scenarios and situations for Windows clients and Windows servers. There's a policy analyzer that you can use to compare your GPOs versus, or compare the group policy objects that Microsoft provides with your current configuration. So you can kind of see what Microsoft is suggesting for different types of systems, for different scenarios. And you don't have to agree, right? You can come in and you can change those settings, but you don't have to start from scratch. Imagine how difficult it would be to sit down with those 4,000 settings and say, okay, which ones do we need to make different than the Microsoft default settings? Well, the SCT is going to help you not have to start from scratch. So I would encourage everybody to download that. If you haven't played with it, get some experience with it, use it, see what it can do. It's very powerful and very useful, and you're not always going to agree with Microsoft's recommendations, but you can make good decisions, and you have a framework to start from. Much easier to take somebody else's first draft and then modify it. Now, hardening in terms of Azure AD and Intune. So Intune, as I say, is a combination of MDM and MAM. Mobile device management is more intrusive and so more thorough when it comes to security. So we'd like to make a lot of MDM settings to improve and harden the security of the operating system. Mobile application management, MAM, can be used to improve security for applications, but that's really outside of our context here. We're focusing on operating system hardening right now. So what we're going to do with Intune, and the concept is the same even if you're not using Intune. You might be using somebody else's MDM, and that's fine. But we have this concept of device configuration profiles. And what they're going to allow us to do is do the same kind of thing that we might do with group policy. We're going to have and maybe the Security Compliance Toolkit. We're going to create a group of settings and say, hey, here are the operating system settings that we think are appropriate for a file server, okay? And then that's going to be a profile, and then we can apply that to groups in Azure AD, bullet 3. We're going to deploy those settings via Intune. Now, the problem is, with Intune, we don't have as many settings as group policy. Well, kind of a problem, but kind of a good thing too, fewer decisions to make. But we're actually closing the gap, and Microsoft is adding settings to Intune all the time. So the device configuration profiles and the security baselines that we can build in Intune are getting to be pretty sophisticated with lots and lots of settings. Another thing we can do, last bullet on this slide, is we can automatically enroll devices into Intune when they join Azure AD. So that's a good thing for security, right? So we have devices that are joining Azure AD, great. Let's enroll them automatically into Intune for MDM, and then we can deploy those security configuration profiles, those device configuration profiles with a bunch of security hardening settings in them via Intune. And now it costs money, right? You have to pay for Intune extra above and beyond your other licenses. It is also part of something called the EMS, the Enterprise Mobility Suite, which also gives you Azure AD Premium and some other good stuff, but it does cost you something. So it's the Intune capabilities are not free, but they do now a pretty good imitation of group policy configuration management in an on-premises network. Now, if we don't have devices that are joined to Azure AD, like typically a lot of tablets will join to Azure AD if they're primarily cloud devices. But what about devices that maybe a laptop or maybe even a desktop, but a laptop might be used for an on-premises network, might also be used for cloud-based computing. So for that situation, if it's a company-owned device, we might look at registering it in Azure AD. So that makes a device known to Azure AD. We can't manage it quite as much as a device that is actually joined to Azure AD. So this is often done for BYOD scenarios. People who have their own device, they want to use their own personal device at work, fine. We can register that device with Azure AD. We won't take total control of it like we might do with a company-owned device in which we would do an Azure AD join. So we can also do auto-enrollment in Intune for this scenario, BYOD scenario. This works off of a certificate system, user certificates in the case of registration. It's a computer certificate in the case of an Azure AD join, by the way. But we can still perform some management with devices that are registered with Azure AD using Intune. So that's pretty cool. And in fact, you can do some management with group policy and some management with the Intune MDM. In fact, if you take that a little bit further, you can have what is called co-management, where we have Intune doing some things, and we have Endpoint Configuration Manager, Microsoft Endpoint Configuration Manager for the on-premises scenario, managing other things, so we can kind of divide up the configuration management chores between those two environments. Kind of complicated, but it does allow us to sort of mix and match some of the capabilities from our cloud-based tools and our on-premises tools during this transition period. Or some organizations are probably going to stay that way. A lot of companies are probably going to stay in that hybrid mode where they're not going to give up their on-premises networks completely, but they're going to be doing a lot of things in the cloud. So the hybrid model, Microsoft sees it sometimes as a transitional model, and they see that everything is going to be managed in the cloud. It's not the case for all organizations. Some organizations will stay hybrid. Okay, so last thing we want to talk about here in this first topic is operating system isolation. So updates, very important, operating system hardening. Configuration management, use the SCT, build some baselines, apply those, do some monitoring, reporting, which systems don't comply with the baselines. We've got to remediate those guys, see why they don't measure up to our kind of security baselines, the settings, the configuration settings that Microsoft recommends and that we agree with. We could go beyond that. There are some cases in which we might want to isolate operating system environments even further. So a couple of, actually there's several ways to do that, but here are two popular ones, the VDI method and then the Windows Sandbox, which you may not have played with. Virtual desktop infrastructure, you're probably familiar with this concept. It's a controlled environment whereby we have users basically connecting to either sessions on a server or actual virtual machines, Hyper-V virtualization hosts, and running systems that way. So virtual desktop. They could be shared sessions, sort of what we used to call terminal server using remote desktop, or they can be actual full-fledged virtual machines, and those would be based on Hyper-V. And in those cases, we have some isolation, right? We have an abstraction to some degree, and so we have the ability to isolate those virtual desktop instances. And that's fine. We also have Windows Sandbox. I think we're going to talk about containers here also on the next slide. Windows Sandbox has been around for a couple of years, but a lot of people still haven't played with it. This is a way on a Windows 10 system that you can run applications with something called VBS. Now, that's an acronym that you're going to see a lot. Virtualization-based security. What that does, what that means is it's kind of a way of leveraging some Hyper-V capabilities, some virtual machine capabilities for specific security-related purposes. So what we can do with VBS, for example, is we can take some pieces of the Windows operating system and run them in a little mini virtual machine. It's not accessible through remote desktop or in any of the normal ways that you would access a virtual machine. But it is nevertheless a virtual machine that restricts and walls off, for example, the LSA, the Local Security Authority in Windows, which controls credentials and logon. So VBS often requires a TPM chip or TPM capability. It could be emulated like the Intel version is. And UEFI, in some cases, is going to be required to use VBS. But we can, in the Windows Sandbox, use virtualization-based security here, assuming we have the supporting hardware, to kind of create a fresh instance of Windows 10 on top of our regular device. Not quite as complete or full-fledged as a Hyper-V virtual machine would be, built on the host system, based on the host system. You have connectivity to the network as well, but just kind of an isolated version. And then when you're done, it's gone, right? When you leave it, it's like a streaming version of Windows, if you want to think of it that way. When you terminate that sandbox session, it's gone. There's no footprints. Now, containers, yet another way of doing operating system isolation. So a lot of times when we're doing development, right, application development, or if we're doing beta testing, maybe we're in the in the Windows Insider program, and we want to do separate machines. I recommend that if you're in the Windows Insider program doing betas, that you keep those machines completely off of your network. But anyway, containers are a lightweight environment. They're able to run on premises. They can run in the cloud. Containers is actually a role in Server 2019. And the concept kind of came from Docker. In the Linux world, Docker engine is installed. And so what we can do is, with containers, they are really, the concept is, let's spin up something like a virtual machine, but let's do it really fast. So, for example, a Windows container is going to actually share a lot of the core pieces of the operating system with the host device. A Hyper-V container, the other kind, you see the bullets here towards the bottom of the slide, actually is better isolation, but doesn't spin up as fast because the container is not sharing the OS kernel with the host machine. And so if you want to use Hyper-V containers, more isolation, but you need the Hyper-V role as well as the containers role on Windows Server. But what we can do in these cases is is very, very useful for application deployment in the cloud. Containers are lightweight, they spin up quickly, but also very good for development work because we have a higher degree of isolation from the host and from the rest of the network. All right, so let's keep it going, and let's talk about application hardening. And I think we can probably cover this topic before we get to our first break. So restricting apps and settings. So going beyond the operating system now and talking about hardening applications. And you say, well, how are we going to do that? Because every application is a little bit different, right? We can do configuration management for applications and updates, right? As the question was raised about WSUS and deploying updates. Well, there's a few things that we can do that are broadly applicable, but you're right, a lot of application hardening is going to be configuration management for the specific application. So we can still, for some applications, use the SCT, Security Compliance Toolkit, Office, Edge, and a few other things. But we can also do some things with App Locker and Device Guard and app protection policies. And those are not necessarily specific to any one application, but they are broadly applicable. And so one of the things that we really want to look at is creating an allow list of applications that people are allowed to use. And that's kind of the focus of App Locker and Device Guard. And then in terms of restricting what applications can access and where the applications can get data and where they can save data, that's something that we can look at in the context of what are called app protection policies, which is something that we can deploy via Intune. Okay, well, let's start with App Locker because App Locker is around for a long time. A lot of you may have worked with it. We have some issues with apps that people install on their systems that are not vetted. So possible security risks, possible damage, user confusion, adding to complexity, making it harder for trainers and support staff, making it tougher to troubleshoot. So generally, what we want to do is limit people's ability to install whatever they want onto their systems. And as you probably are aware, some organizations are much more rigorous about this than others. Some are very, very strict indeed. Some are a little bit more lax. I've done a fair amount of consulting with educational institutions in years past, and they have to be very accommodating because you never know what software a faculty member might want to run or what software a student might need for a particular research project. So they have to be very, very broad. I've also done consulting for the Army and other Department of Defense entities, and they tend to be very, very strict. So you got a range, and you get to decide how strict you want to be. And I just want to tell you about the tools that are available. And it's a little bit confusing because there's two tools that do kind of similar things, and it's not always obvious which one would be the appropriate one to look at. So there's AppLocker. Let's talk about that first. It's not an anti-malware tool. It's designed to address issues with non-tested, non-vetted apps. Okay, so how does AppLocker work? Implemented by group policy. So we can do these settings on a domain-wide basis or on an Active Directory site basis or on an organizational unit basis. So this is on demand only. There's not a scheduled scan. It's not anti-malware. It's not going to periodically do a sweep of systems to see which are running rogue applications, right? So it's only when the user wants to run an application that AppLocker kind of kicks into gear and says, should we allow that application to run or not? Now, very important, if you haven't rolled this out and you're thinking about rolling it out, you might want to start with audit mode versus enforcement mode, bullet 3. Because audit mode means what we're going to do is we're going to sort of track who would get denied. If we deploy some policies that say, all right, we're going to restrict applications in our network to X, Y, and Z, who's going to get denied? We want to hear about that. We want to see what that is in audit mode without actually enforcing that denial. Because once you start denying applications, you're going to get some phone calls, right? People are going to say, hey, and some of those phone calls might be from VIPs, very important persons in your organization, and say, what is the deal? I am trying to run this application. I can't do it. I'm denied, and I've got a deadline here, and this is very important, and heads will roll and so forth. So audit mode to start with, and then enforcement mode. You can flip that switch later on. You also have to make a decision with AppLocker in terms of whether we're going to use a default allow scenario or a default deny scenario. Now, the default allow scenario is what we had to do, for example, with some of the universities that I've consulted with. As a default allow, but there are certain applications that we know create problems, and we can block those. So that's the default allow. Let people install what they want in terms of their apps, but the known troublemakers, and we talk to our tech support folks, and if we have a help desk database, we look at that, and we say, gee, all right, there's some applications that are known difficult, that are creating issues for us. We're going to deny those. So that is better than nothing, but not as secure as the second option, which is the default deny. In the default deny scenario, you can't run anything unless we have approved it, right? If it's not on the list of allowed applications, you won't be allowed to run it. That is more secure, as you might imagine, but it is also more work to set up because you've got to think ahead of time. You're going to say, well, all right, what do people need to run? What might somebody legitimately need to run? And so you're going to create a list of an allow list of applications that people will be allowed to run. And then beyond that, they're going to be denied. Okay, that's more secure, but you potentially are going to have a bigger impact on user productivity if you don't have a really good allow list to start with. So the rule types that we can create in AppLocker, EXE, APPX for Microsoft Store apps, MSI, DLL, scripts, and so forth. One of the things that's going to help you, if you want to set this up, is you can create a golden computer that has all the applications that you want to make allowed in your group policy AppLocker architecture here. And then you basically just tell Windows, figure it out. Look at this computer. It's got all the applications on there that are okayed by our certification team. We want to create the allow rules from this golden computer, and it'll generate those rules automatically. So that saves a bunch of time until later on you realize what you forgot. So you're going to get a phone call from somebody that says, hey, I'm trying to run the calculator program, and it's saying denied. And you say, oh, that's right, we forgot about calculator. Somebody might want to run that one of these days. So a lot more work, but still good security. Now, there's this other method, the second method that I was talking about, which has this name, Microsoft Defender Application Control. One of the things you're going to find as we go through this morning session is that everything is Defender. Defender this, Defender that. Very, very confusing because there are so many different technologies and tools that are prefaced with Microsoft Defender. They used to call them Windows Defender. Actually, a couple of them they still do call Windows Defender Firewall, for example. But mostly they've rebranded it all to Microsoft Defender. So this is something that used to be called Device Guard, which was actually a terrible name. I'm kind of glad in this case that they changed it, because Device Guard really didn't have anything to do with devices. So the idea here with Microsoft Defender Application Control is similar concept to AppLocker, but we're not going to have a default deny mode. We're just going to, or we're not going to have a default allow mode. We're going to have a list of things that you run, and anything not on the list you won't be able to run. So we're going to use a manifest or a signed catalog of applications that we are saying, thumbs up, these are allowed to run. We're going to create a catalog. We're going to sign it either with the signtool.exe program, or you can go to the Microsoft Store for Business and sign it that way. Those are free. You can set that up for deploying apps in your environment. Then we're going to add a certificate to something called a code integrity policy. We're going to deploy that code integrity policy with, for example, group policy. And then we'll deploy the catalog itself, for example, with configuration manager. Sounds complicated. It's not that bad, but it's no walk in the park. There's a lot of planning that goes into this. But basically, just understand the concept. We're going to say, these 10 applications, we want people to be able to run them. Anything else, we want to be denied. That's Microsoft Defender Application Control. And so you create this catalog, you get it signed, you push it out with group policy, and then it's going to be enforced. Now, let's see, what else do we have on this? You can improve this Defender Application Control architecture with VBS. Right? Remember I told you we were going to be talking about VBS a lot. So VBS is going to require hardware-assisted virtualization, which is pretty much on all processors these days, on business machines at least. Second-level address translation, there might still be some older systems that don't have that. And an I/O memory management unit is a good thing. So if you have those pieces in your standard hardware platform, then you can use Defender Application Control with VBS. You turn that switch on with a group policy setting, and that's going to make it even better. We can improve it even further if we're using UEFI systems that we can set with secure boot, which restricts the ability to boot to non-Windows operating systems. Okay, so by the way, those code integrity policies that we use with Defender Application Control can also be applied to device drivers. In fact, that's sort of where this idea started, really. Probably a lot of you know that, for example, we're not allowed to run 32-bit drivers on a 64-bit Windows system. So code integrity policy is kind of more broadly applicable, not just to applications, but the application control feature uses code integrity policies for that list of allowed applications. Now, the big question becomes, we've talked about AppLocker and we've talked about application control. The big question then becomes, which one do I use, right? So we didn't really have good guidance from Microsoft for a while, but they finally addressed the question. They said, all right, if you have the hardware, if you have the ability to do VBS, if you have SLAT, if you have I/O MMU, if you have TPM, all those good things, then they suggest application control because it's a more secure solution than AppLocker. Now, if you don't have the necessary hardware to do the VBS piece, or if you need the default allow scenario, right, where you're generally just creating a list of software that is banned or restricted, then you can still use AppLocker. Okay, so whichever way you go, so that's the guidance. Whichever way you go, be careful. My last bullet here: be careful about locking the keys in the car. Right, it's especially with AppLocker. Early on with AppLocker, people would create some rules, and then they would forget, and they'd have overly restrictive AppLocker rules, and they wouldn't be able to manage their networks anymore, right? So you have to be a little bit careful here. There's some default rules that Microsoft came up with that help prevent that from happening, but just make sure that you're allowing enough things to be run so that you can manage your systems and networks, right? You don't want to lock yourself out of administering the network. All right. So those are some ways to restrict the applications that you can run in your environment. Now, there's something else. The last thing I want to talk about here before we get to the top of the hour, and that is application protection policies. Okay, so these are implemented through Intune. Now, you can have these. There are similar capabilities in other MDM solutions, so you don't have to necessarily have to use Intune for this. So this is the mobile application management side of Intune. Remember I said Intune can provide both MDM and MAM. So MDM broadly, if you want to distinguish between those acronyms, MDM kind of hardware, MAM applications, kind of a broad, very sort of not super accurate, but a good broad way of understanding it. So some of the things that we can do on the application management side is, for example, we could require specific credentials in order to open a business app. So for example, a personal identification number or other credentials to open a business app. In other words, if somebody wants to run this app, well, they're going to have to provide their PIN. Now, a little bit of terminology here, because this can be a bit confusing. App protection policies per se, as the lingo is used in the Microsoft world, are for iOS devices, Android devices, in other words, non-Microsoft operating systems. We still have some of these capabilities in terms of app protection policies, but in Windows, we refer to them as Windows Information Protection, or WIP. Same kind of context. We're going to look at WIP a little bit later in the context of data protection. So one of the things that we can do is we can sort of put data in a fence, and we can say corporate data is going to have to come from these places, our corporate network, and corporate data can't be saved on a mobile device to somebody's personal storage area if it's a BYOD device. So you can kind of put some boundaries using WIP in terms of where application-related data comes from in terms of documents that are open, and where it is saved to in terms of the BYOD scenario. We don't necessarily want corporate secrets being saved to the personal storage area of somebody's iPhone, right? Or somebody's tablet. So that's kind of the concept of app protection policies, but just kind of understand very broadly that the terminology in the Windows world is for app protection policies to apply to non-Microsoft operating systems. WIP, Windows Information Protection, applies to Windows. And we'll talk more about WIP a little bit later. Okay, so that's very good. What I want to do next, I've got actually a couple of minutes before the top of the hour, so hooray. What I want to do is let's go ahead and start our discussion of credentials. We'll go for 8 minutes, and then we'll take our first break. But obviously, this is one of the biggies, right? So our third topic, protecting credentials, lots of different tools and capabilities here. So this is a big deal, and this tends to be the focus of a lot of security audits. So some of the things that we can do here: passwords, biometrics, which you've heard a lot about certainly in recent years with Windows Hello, for example, facial recognition. There's MS Defender Credential Guard. What's that? It's another one of those Defender things. So a lot of memorization here. NTLM blocking. We'll talk about smart cards, physical and virtual smart cards. Certificate-based authentication, read-only domain controllers, and Azure MFA, multi-factor authentication. So lots of topics here in this broad category of protecting credentials. So let's get started with a little discussion on passwords. So, Microsoft keeps talking, a lot of organizations keep talking about how we're getting away from passwords. Fine, great, we will love that day when it gets here. For most organizations, we're still using passwords. So we still need to manage them. We still need to have password policies. Two places we can do that in Microsoft networks: on-premises networks, group policy, and then cloud-based devices, Intune. So the things that we're going to manage, I think everybody's probably pretty familiar with this. Password policies, length, right? Minimum length, that's the key one, right? Complexity, upper, lowercase, special symbols, numbers, that's great, but it doesn't help nearly as much as length. If you look at the math, length is really where you get the secure benefit, which is why a lot of organizations are pushing passphrases as opposed to passwords. Obviously, history, how many can you reuse, and then minimum and maximum age. With fine-grained password policies, in the last several years, we've had this capability in Windows Server. What we can do, and amazing to me that a lot of organizations still don't take advantage of this, we can create password policies that vary depending on subsets of our user population. So some people are working on secure stuff. Some people are working with intellectual property in your environment. And so they really need to have good, strong passwords. Other folks, temporary data entry, seasonal employees, they may not need as much security, so they could maybe have somewhat easier passwords that are not as burdensome. So what we can do in Windows networks is we can have different password policy settings for different subsets of our user population. The way we do that is through password settings objects, or PSOs. So we can create these in an administrative tool called the Active Directory Administrative Center, and we could build a PSO and we link it to a group, Windows group. Now you say, well, people can belong to multiple groups. So what if I have somebody who is in 2 different groups and they have different PSOs with different password requirements, different password policies? There will be a precedence value that we can set with each PSO that will be a tiebreaker and determine which PSO is going to be preferentially applied if multiple ones are in the scope of a particular user's group memberships. We also have, so that's something you can do. You can have PSOs to Windows groups. So you can have 30 different groups in your environment, and each has a different password policy, if that's appropriate. I mean, we don't want to make rigorous, burdensome security requirements for people where it's not appropriate, where they don't really need it, or they're not really dealing with data that's all that concerning in terms of the security risk of a breach. We also have, of course, account lockout policies, and those we can implement group policy on premises, and then MDM for our cloud devices. Threshold, how many lockouts, how many bad attempts before you get locked out, how long are you going to be locked out, and then what's the reset interval, right? Now, I should mention briefly in this context, managed service accounts. I don't know if you are familiar with that phrase, but we have passwords associated with accounts that are used by applications in some cases. So you might have some databases that have actually, that have to operate within the security context of a particular user account. And that user account is going to have a password. And there have been problems in the past with databases that suddenly stop, right? What's going on? Why is our database crashed? And it can be because the service account's password has expired. There's not a user interface to update that password or change the password because the service account is designed for use by an application. Well, we have this concept now called managed service accounts, or MSAs, and there's a variation on the theme called group managed service accounts now. And they have passwords that will automatically renew, kind of like, I don't know if you are aware of this, but you know that Windows devices, when you join a domain, so you get a Windows 10 laptop, you join it to your Active Directory domain, that relationship, that trust relationship, is actually implemented by passwords. They're just behind the scenes. You don't see them, and they automatically renew. I don't know, maybe some of you have seen a situation where you log on, you try to log on to your domain with your Windows 10 device, and you get an error message saying the trust relationship between this device and the domain has failed or could not be established or something like that, right? So if you've ever seen something like that, well, that's indicative that the password has gotten out of sync, and you have to reestablish that trust relationship by resetting the account. Will typically work. But anyway, it's basically the same method of automatically renewing passwords in the background. And so there's not a user interface for that. But with managed service accounts, that's less of an issue, so your databases aren't going to crash as often. So getting away from passwords is a great thing for several reasons. One being that passwords are stored in a central place, for example, on a domain controller. And so that's a nice target for hackers and identity thieves and so forth. And so any Active Directory domain controller, and we're going to talk more about read-only domain controllers toward the end of this section, but that's a very tasty target. And so that central database of usernames and passwords is something that, maybe we'd like to get away from that, make life a little tougher for the bad guys. And biometrics is one way to do that, because as you can see in the bullet 5 here on this slide, biometric data is actually stored on individual devices, not centrally. So in Windows 10 and 11, we have something called Windows Hello. There's an unmanaged flavor of that and a managed flavor. The unmanaged is for access to your local devices. And that works with facial recognition, iris, not retinal, but iris patterns, and then fingerprint recognition. The facial recognition, honestly, in Windows Hello has been something that has really taken a super long time to develop. It was much touted by Microsoft at the introduction of Windows 10. The problem is it requires very specific hardware support. And so, I see a couple of questions in the Q&A box. Let's see here. Okay, yeah, we're going to get to Microsoft Defender in the enterprise. I'm going to chat more about that a little bit later, so hang tight for that. And biometrics, I'm not sure this next question, is this the same for AD in Azure? But you can use biometric. We can use, if you're asking about the password policies, we can do those with Azure and MDM with Intune. And with respect to biometrics, Windows Hello, we can manage that for Azure devices as well. So the facial recognition, though, does require 3D infrared capable cameras, and there just aren't all that many of those. I mean, there are some that you can get to retrofit, but generally the number of laptops and tablets that have that built in has not been what Microsoft was hoping to see. Fingerprint recognition is pretty easy. You can retrofit that through a simple $10 USB device, so that's no big deal, although a lot of devices do have fingerprint reader built in. The iris recognition also is something that you have to have the specific hardware for that. Now, the managed flavor of this is Windows Hello for Business, and they used to call it Microsoft Passport, and so the terminology has changed a bit. But Windows Hello for Business requires a lot of pieces if you want to implement it on premises. So you got to have the Active Directory schema being at least the Server 2016 level. You need to have a Active Directory certificate services installed. You need to have Active Directory Federation services installed. It's kind of complicated, a lot of moving parts to implement this, but you can set it up so that you can leverage that biometric authentication capability to log on to the domain. It's a bit easier, actually, if you're looking at the cloud, because you can just use Azure AD and Azure multi-factor authentication. You don't need to configure all the other stuff that we have to configure on an on-premises network. So biometrics, very helpful in the sense that there's no one sort of central database for biometric credentials. Now, another MS Defender thing called a little different. So we've already talked about, we should try to keep track of this. We've already talked about Microsoft Defender Application Control. Now we're going to talk about Microsoft Defender Credential Guard. So this is something that is a good idea if you have the hardware to support it. And again, it's kind of the typical VBS stuff, as you can see towards the bottom of this slide. So if you have TPM, Trusted Platform Module version 2.0 or newer, second level address translation, then you could probably use this, and it probably would be a good thing to do. So credential hashes are actually stored in memory, and they can be used to in something called a pass the hash attack. So let's say you have a device sitting here in your environment, and Joe user logs into it, and at some point Joe needs some help and snags Lucy, and Lucy logs in, and Lucy, let's say, is a domain admin. And then everybody goes away for lunch, and an evildoer comes in. Well, Lucy's credential hash is still in memory, and that can be harvested and then used to authenticate with domain admin credentials to other resources on the network. So it's not a good thing. Microsoft Defender Credential Guard stores those hashed credentials in a protected, one of those little baby kind of virtual machines that I was talking about a little bit earlier. And so an isolated, like a mini Hyper-V VM, and that protects it from being harvested by the evildoer that might just wander in during the lunch break. So this is going to protect domain accounts. It does not, as I point out here in bullet 6, does not protect against for local accounts or Microsoft accounts or Azure AD accounts, but it does protect against this kind of pass the hash attack with domain accounts. We're going to configure this with the group policy, and there's even a flavor for supported remote connections, remote credential guard, accessing other systems with remote desktop protocol. We can implement credential guard in that case as well with the quote-unquote remote credential guard. So that's Microsoft Defender Credential Guard, basically designed to stop that one type of pass the hash attack in terms of credentials being compromised. Okay, other credential-related stuff. So NTLM versus Kerberos. So most of you probably are aware if you've heard the term Kerberos. So this is the authentication mechanism that is used by default in Active Directory. The thing about it is NTLM can also be used. NTLM is the older authentication method. The cryptography is not as good. It is vulnerable to certain types of attacks that Kerberos is better at resisting. But there are some apps and utilities and services that still use NTLM. Stands for NT LAN Manager, which is going way back in time. So that's where the acronym comes from. So one of the things that you can do that's a good thing for security, and a lot of you might not know this, but you can find out, hey, what apps, what utilities, what programs, what services might still be using NTLM, that old authentication mechanism, excuse me, in our environment, and let's find out which they are so we can turn on NTLM auditing in group policy. I'm not going to go into the details of how it is, but you can look them up if you want to do this, but it's a good thing to do. Check incoming and outgoing traffic, check your domain controllers, and then you say, aha, all right, so these four things, these four services or apps are using NTLM. So upgrade them, reconfigure them, get to the point where nobody's using NTLM authentication. And then when it's safe, last bullet on the slide, use group policy to turn it off, okay? Disable it. And that's going to improve security because you'll only be using Kerberos for authentication in your Active Directory environment. Okay, now in terms of authentication, there's this principle of security that talks about multiple factors. Something that you know is a password, right? So you have your username and then you know your password, maybe, right? If you hadn't had to change it 15 times this year already. Something that you have, right, might be a smart card, right? So that adds another factor. Something that you are might be, you know, the pattern of your iris or the shape of your face. And so the combination of something that you know, something that you have, and something that you are, the more of those things, those are broad factors or categories of factors. So with a smart card, we have something you have, a card, and something that you know, a personal identification number. So they, in the past, have been great but expensive, right? Because you got to have devices to read the smart cards. They might be integrated into keyboards. There might be separate little smart card readers that you can retrofit via USB. And then you got that whole infrastructure for producing the cards and so forth. So the virtual smart card reduces the cost. It might be something that you look at because you have this chip that is part of the motherboard of just about all business class computers these days called Trusted Platform Module, TPM. It's like a smart card that's always installed, right? It's a special cryptography chip. It can store certificates. It can store cryptographic keys. It's supported in Windows 10, so you can actually leverage that and pretend that that's like a smart card that is always installed. And so the virtual smart card is a capability that you might want to look into if you've thought about smart cards, but the cost has kind of put you off. If your hardware platform includes TPM as a standard on your sort of bog standard corporate devices, then you might be able to use that capability. So that's kind of cool. All right, so also we can use certificates for authentication, and certificates, broad topic. So we have public and private certificates that can be issued for particular purposes. Here we're going to be focusing on authentication. And often we do see certificates used in remote access. So VPNs are often certificate-based. Web access, right? You access a secure website using SSL, HTTPS. There's a certificate involved. That web server has a certificate that your device trusts. Wi-Fi, IPsec encryption, IPsec authentication, smart cards. So certificates can be used for authentication of both users and computers. So we're not going to get into all the details of certificates here. It's a very complex subject. But we do have something called Active Directory certificate services, whereby we can set up a private certificate authority. We can generate our own certificates, basically. And that architecture is going to consist of root and subordinate certificate authorities. So those are going to be servers that you're going to set up. There will be online responders, which are going to be servers that will reply to requests from connecting devices that say, hey, I want to check on whether a particular certificate has been revoked or not, or whether it's expired, or is it still valid. And then we can use group policy for automatically enrolling certificates so that we don't have to manually do that. So certificate-based authentication is a good thing, especially for when we're talking about web access, when we're talking about remote access via VPNs. You can do other types of authentication with virtual private networks, VPNs. You can do password-based, but it's not as strong, right? So if you want to increase security, look at using certificates. So just kind of a few tips here for this environment, and recognizing that understanding ADCS is something that is not something you're going to do in an afternoon. But just a few tips here, just to sort of keep in the back of your mind if you're dealing with this. Make sure that you take advantage of the fact that certificates can be revoked when they're no longer needed. There's a protocol called OCSP that saves bandwidth that you could look at in terms of asking about revocation. You could consider public certificates that you actually buy. There's a public market for certificates. You can buy them if you're dealing with people outside your organization. So if you want to set up, for example, a website that's going to involve customers or suppliers or contractors, then public certificates are nice because you don't have to worry usually about setting up the trust relationship, because most client operating systems are set up out of the box to automatically trust the major certificate authorities in the public space. If you're going to be issuing certificates in your environment for authentication or any other purpose, think about their lifetime. What's an appropriate lifetime? The root certificate authority should usually, in best practices, be kept offline until it's needed to renew subordinate CAs, maybe on an annual basis. Make sure that you're protecting that certificate database and that you have a recovery and restore plan. And we can deploy certificates lots of different ways. So, for example, if we're building a secure website and we want to use SSL and HTTPS for that, we can deploy those certificates via group policy. We can deploy them through something called a provisioning package. I don't know if you've all played with those .ppkg files. So these are created by a tool called the Windows Configuration Designer. It's a free download, and it creates these provisioning packages that can be used to do some custom configuration. User just double clicks on the file, and then it makes some settings. It can install certificates. It can make some configuration settings. So it's sometimes used as a way of customizing Windows 10 on mobile devices in particular. And then, of course, Intune, right? For MDM, we can use Intune to deploy certificates as well. So lots of ways to getting certificates out there. Mainly, we see them used in organizations that are either using smart cards or accessing remotely via VPNs or connecting to and setting up secure websites. Right. Okay. So that's kind of a long section. Two more topics in this section, and then we're going to talk about data protection. So RODCs, read-only domain controllers. So this is kind of a variation on a theme. And again, it's one of those things that's been around for a few years. Kind of surprising to me that more organizations don't take advantage of this. But if you have domain controllers that you need in certain locations that are maybe not the most secure, maybe you've got some branch offices that are, you don't have a separate locked server room, let's say. You've just got a server sitting around someplace, but it's needed for performance purposes, maybe, so that people can log on with reasonable speed. Maybe you have poor WAN connections to other parts of your network where you have full domain controllers. Well, you could set up those branch locations or those less secure locations with a read-only domain controller. Now, the read-only part of it is kind of self-explanatory. You can't do any updates. So if you want to change any user or computer attributes, you can't do it at that device. But it can still log people in. But the main thing about RODCs is that we can control what credentials are stored there. A full domain controller is going to have all the credentials for all the accounts in the domain, right? And that's a lot. It could be hundreds, thousands of folks. So it's a nice target, and it means that if it gets stolen, right, somebody steals your full domain controller, you're going to be resetting a lot of passwords. And that's what I mean in the first bullet by massive remediation. So not necessarily something that we want to do. But what we can do, the cool thing about the RODCs, and the thing to remember from the standpoint of authentication, is we can say, hey, we only want to have a small subset of user account credentials stored on this domain controller. We just want to use it so that people here in the branch office can log on. And if that device is compromised or stolen, then yeah, maybe you've got, I don't know, 10, 20, 30 different accounts that need to be reset, but not maybe 10,000. So that's kind of the cool thing about RODCs. Okay, last topic, something that is actually been adopted to the extent that it's sort of driving us all crazy these days, right? Multi-factor authentication. It seems like almost every time I turn around, I've got to go grab my phone and authenticate something that I'm trying to do. So Azure MFA is supported with hardware tokens, text messages, voice calls, and the Microsoft Authenticator app. So it's free. MFA is free for Azure AD administrators, but if you want to use multi-factor authentication for other users, then you're going to need to pony up and pay some dollars and get a subscription to Azure AD Premium if you want to enable individual non-admins for MFA. So the way it typically works is that we're going to create something called conditional access policies. And these you can create in Intune. And you can create them in Azure as well, Azure AD, the Azure portal. And we're going to specify particular events and or apps, right, that we deem to require that extra level of authentication through MFA, or 2FA for two-factor authentication is another abbreviation you'll see a lot. So for example, you might have a BYOD versus a corporate-owned device. Maybe for the BYOD device, you're going to create a conditional access policy that says, yeah, we want to use multi-factor authentication for this app if it's on a BYOD device, a device that is registered but not joined to Azure AD. Right. Okay. Very good. So just very briefly, you can set that up in the cloud. It's pretty easy, straightforward. You can set up MFA for on-premises networks too. There are more moving parts. It's a lot easier to set it up in the cloud with Azure AD, and but it can also be done on premises. But usually the benefit is skewed toward portable devices. Right. Okay. So I got a little exercise for you here, just for fun, before we get into our data protection discussion. Find the vulnerabilities. So here's a credential protection system. And so let's think about how we might make it better. And I'm just not saying it's bad. It's actually not too bad. But let's say we've got good, strong password policies and good, strong account lockout policies. So we're not going to allow 4-character passwords, and we're not going to let people keep their same password for 2 years running. So we've got strong passwords for policies and account lockout scenarios. We're enforcing by group policy for on-premises. We've got Intune for cloud-based devices in Azure AD. Our devices have 64-bit CPUs, no SLAT, that's second-level address translation. It's one of those things that was required for VBS, if you remember. But we have a nice new version, reasonably new version of TPM, version 2.0. We're using AD certificate services to have secure VPN authentication, for example, with L2TP and IPsec. And we've deployed read-only domain controllers for our branch offices, and we've configured those so that they only store a subset of user accounts as needed by that branch office. So what are some things that, if any, that we might do in order to improve security here? So kind of just think about that for a moment. Let's look at our first bullet. I mean, look, broadly speaking, strong password policies are great, but we could make this even better if we migrated to Windows Hello, biometrics, Windows Hello for Business, right? So if we use biometrics, that's going to strengthen things even more because we have decentralized biometric data. It actually resides on each device instead of in a central location like a domain controller. So that would be one thing we could do here. The other thing that we might want to think about, just looking at the third bullet, if we don't have SLAT support in the motherboards for our common devices in our environment, in our organization, then we're not going to be able to use those VBS-based things, those virtualization-based security capabilities like Credential Guard, right, that we talked about, Microsoft Defender Credential Guard, with that ability to kind of do the VBS thing and protect those hashed credentials that might exist. So just for VBS capabilities, our devices would not be able to use that. So that would be something we might think about maybe for our next refresh of hardware. Some of us are going to be refreshing our hardware sooner rather than later because of Windows 11. I don't know if any of you are up on this, but Microsoft has said, hey, we're not going to support Windows 11 on anything less than an 8th generation Intel processor. I think there's maybe one or two. There's a small handful of 7th generation processors that are supported, but it's not very darn many. And so that a lot of systems that you might have bought maybe 3 years ago are not going to be supported for Windows 11. They might still run it, but Microsoft isn't going to support them. So a lot of organizations are howling and screaming about that and saying, hey, we just bought a bunch of systems 3 years ago, and now you're telling us we can't run Windows 11 on them. And no particular good reason for it, to be honest. I mean, there's some security-related issues like TPM that we can understand, but ruling out a lot of those 7th generation processors seems a little bit strange and not necessary for the security benefits. I mean, in my own office, I've got some of those systems, and I'm thinking, oh, wow. I wasn't really planning on buying a new computer or 5 to run Windows 11. Anyway, but if you're looking at that, if you're looking at a hardware refresh, right, the SLAT capability, the TPM, and TPM is implemented in firmware now. Intel has done that, so you don't even actually need a separate chip. It can be an emulation that occurs as part of the processor's firmware. Right, okay, cool. So let us press on and start talking about data protection. Right, so we're going to talk about protecting data at rest, and then we're going to talk about protecting data in transit. And then in the latter parts of our discussion, we're going to get into anti-malware and auditing. Right, so those are the topics that still remain. So data in situ, for you Latin fans, information at rest. And basically, we're talking here about encryption, but also permissions in terms of file system security, Windows information protection, which I alluded to a little bit a few minutes ago, and then DRM, and then we'll have a few comments about Azure storage. So get into that. So encryption with EFS, this is something that has been around for many moons. EFS is fine. I mean, there's nothing wrong with it. Again, one of those things that I sort of scratch my head and say, why isn't this used more? It has some restrictions, right? It's documents only. You can't use this to encrypt system files, but normally we're concerned with protecting the contents of documents, right? We're not concerned about encrypting DLLs usually. So the idea is that with EFS, and I see a question just came up. Yeah, we're going to get to, I'll get to WIP, but yeah, data leak prevention coming up. Stay tuned. I'm going to get to that topic here in just a few moments. Good question though. So the idea with EFS is that the only person who can open an encrypted document is the person who encrypted it, or any designated colleagues who I've said they're okay, right? So I can make a list of people who I'm allowing to see documents that I've encrypted. And then also, if we have one or more designated recovery agents, data recovery agents, DRAs, then they can decrypt these documents as well. But normally in an organization, we're not going to have very many of those, right? That's for emergencies. So EFS has been thought of as mainly applicable for portable systems, and that's when it's usually used. And with EFS encryption, it's tied to the user, not the machine, right? Which is kind of an important thing. Put that in the back of your mind. We're going to come back to that topic a little bit later, right? So you turn this on, you encrypt some files, only you can open them. So you say, well, okay, this is certificate-based. Do I need to set up my own PKI? Do I need to install Active Directory certificate services and the root CA and subordinate CAs and all that stuff? No, you don't have to. You can, but EFS can actually use self-signed certificates. So if you don't have all that rigmarole with an AD certificate infrastructure, that's okay. You still use EFS. Another cool aspect of EFS is that you don't have to be an administrator to encrypt your documents. You can log on as a standard user, and you can encrypt your stuff. Now, one important point, this third bullet, a lot of people don't understand this. EFS does not protect against document deletion. So anybody who has local admin rights on a Windows system is going to be able to delete a file. Right? So this doesn't protect against that. This is designed to protect against opening, right? The wrong person opening a document and getting the information inside. But it doesn't protect against deletion necessarily by an admin. So we can configure EFS with group policy. We can actually require it for specific folders if we want. And then I'm not going to get into the super details about how the encryption works. It's kind of a combination of public key and symmetric encryption. But the file header for the file that you encrypt reflects the known data recovery agents. And so if you add, the gotcha there is that if you add a data recovery agent later on, you need to update all the encrypted files that were encrypted in the past so that they know about the new DRA, so that the new DRA is able to decrypt those previously encrypted files. But nothing wrong with EFS. It's pretty fast. You don't really feel a slowdown. It's transparent to users. And yeah, if you don't use it in your organization, you might think about using it for your personal stuff. You go on vacation, go take a trip. You might want to use EFS to encrypt any personal identifiable information, any stuff that you might have on your laptop that's PII. All right, that's been around for a long time, and it works. Now, all the press in recent years, though, has gone to BitLocker, which is newer and shinier, and it is a different animal. BitLocker is full volume encryption. So it's going to encrypt everything on a volume. It can handle data files, data volumes, and it can also handle system files on an operating system volume. There are different settings in BitLocker for operating system volumes versus data volumes. The idea here is that we need a startup key to be present at boot time, and the volume will be decrypted using that startup key. So it's kind of cool. And you know, you can use it in Hyper-V now, your virtual machines that you're setting up in Windows Server 2016, 2019, whatever. And you can BitLocker those guest VMs because the TPM can be virtualized. The TPM is typically where we store the startup key for the encryption of BitLocker drives. So we can use this for servers. We can use it for workstations. Any servers that might be able to walk out the door, right? Virtual servers. The thing with BitLocker, one of the things to remember here, distinguishing it from EFS, is that the encryption is tied to the machine, not to the user. And so how is that encryption tied to the machine? That's kind of the interesting story. So this, if you want to use it on a server, it's a feature that you have to install. So we've got two partitions, at least, on a BitLocker machine. The first partition is not encrypted, and it's where we start the boot process and pull that startup key out of the TPM chip, typically, and then use that to decrypt the big second partition, which is the operating system and data files and so forth. So that key can live various different places. 99 times out of 100, it lives on a TPM chip in the physical machine. But you can also store the key in a USB drive if you don't mind popping a flash drive into your computer every time you want to start it. Kind of a pain. Virtual TPMs, like I mentioned, are available on Hyper-V virtual machines. The newer ones, anyway. The Generation 1, kind of an older style virtual machine, can use something called a virtual floppy drive to store the startup key. But the decryption is transparent to the user. So a user boots a BitLocker machine, they don't see it. They don't feel it. Might be, I don't know, a few percentage points slower, but nothing that you would feel. So it's nice from the standpoint of being transparent to the user with the TPM chip. And so the cool thing about this is that it protects against the scenario in which, let's say you are traveling, you've got a laptop, you've got a BitLocker hard drive. Somebody steals your hard drive. They're going to steal your laptop. And they take the hard drive out, and they hang it off as an external drive on a system that they have full admin privileges to. They're not going to get in because that removed hard drive is not going to see the startup key, right? Because it's been divorced from the TPM. It doesn't see that TPM, it doesn't see the system board because that hard drive's been pulled out and put on a different machine. So it's very, very good protection from that standpoint. And it's also, it hasn't actually been cracked except in some really weird specific scenarios over at Princeton that are actually not even likely to be duplicated anymore these days with current memory technology. So BitLocker also, as an extra bonus, does some pre-boot environment checks If you're using UEFI, it can do secure boot. But basically, it's going to check and see, hey, is this the same machine that it was yesterday? And is the environment basically the same? So that's kind of a nice extra thing in addition to the encryption. Now, you say to yourself, okay, well, this is kind of cool. It uses the startup key in that TPM chip. And what happens if I need to replace the motherboard on a computer that I've used to encrypt the hard drive with BitLocker? I get a new motherboard, pop the hard drive on there, and my system won't boot because the TPM chip is empty. Well, in that case, we have a recovery mechanism. So there are recovery keys in BitLocker, and we're going to store those, or escrow them is the term, typically in an Active Directory on a domain controller in an on-premises network. We can also escrow those keys in Azure AD in a cloud environment. And we'll get the recovery key, and then we can enter that, and then we can re-encrypt the drive, and then it'll be happy with the new TPM chip and the new motherboard. There's also a data recovery agent capability in BitLocker. So these are people who are able to decrypt an encrypted BitLocker drive, much as we have with EFS. There was a console called the Microsoft BitLocker Administration and Management Tool, MBAM, but that's been retired. So that's, in a nutshell, BitLocker. Yeah, you don't need to do that on every machine. But if you've got some machines that are portable and they have some sensitive intellectual property on there, it would not be a bad idea to implement this. But just make sure that you can set group policies that mandate the escrowing of the recovery keys. Because if you don't have the recovery keys and you wipe your TPM or you get a motherboard replaced or whatever, there's no way in. You can pay Microsoft $1 million and they won't be able to crack it. It's not like they can crack the code. Removable drives, flash drives, can use BitLocker to go. That's password based. Obviously, you can't use a TPM in that case because the TPM is going to change for every different system you pop the flash drive into, but that's password based. A kind of a cool, nice side benefit is that we can use BitLocker as a way of saving some money when it comes time to decommissioning drives. So decommissioning drives is a big security hole in some organizations. Just recycle their old machines and maybe they do a format which doesn't really do that much. With BitLocker, if you've got a BitLocker drive, all you have to do is clear the TPM chip. Nobody's getting into that drive. You don't have to drill holes in it. You don't have to put it through a big old industrial shredder. You don't have to pay somebody to do that. So it's a nice way to save some money when you're decommissioning old drives. Right. Okay. Data at rest. Other ways to protect data at rest. So file system security, Windows information protection, and DRM. And then a couple of comments on Azure storage. So NTFS permissions. I'm not going to get into this in any great detail because it's not super new. Most of you are aware about NTFS permissions. It's effective, but only if the documents stay put, right? It requires an NTFS volume. So if you take a file or a folder that's been protected with file system permissions, who's allowed to read, who's allowed to modify, who's allowed to change permissions, that's fine. But as soon as you copy that to a flash drive that's been formatted with exFAT, for example, or FAT32, permissions are gone, right? So you don't have that protection anymore. But if the documents are staying put, like on a file server, great. We have standard permissions that are kind of combinations of the more granular special permissions that are used. We have rules for inheritance, right? Subfolders typically inherit the permissions of the parent folder. And so we have these access control lists that are made up of access control entries that say things like members of the engineering group are allowed to read the documents in this folder, right? So that's an access control list. Now, we have something, some people still don't know that this has been out there for a few years. Conditional access is kind of cool. I don't know if you've played with this at all, but there are rules, conditions that we can set up that go beyond NTFS permissions. And these conditional access rules are based on attributes in AD. So kind of the classic example is the department, right? So if a particular computer is a member of the engineering department, that's an attribute in Active Directory, we can create a rule, an access rule, based on that Active Directory attribute. So that's called conditional access, and it is also something that we can layer on top of NTFS permissions. Okay, so file system security, something that most organizations could stand to have their file servers audited. And let's look at those NTFS permissions. Let's think about maybe conditional access rules based on Active Directory attributes. For example, you could say for a particular file server, hey, I've got a folder here. I only want it to be accessible by people whose user account in AD is the engineering department and who are working on computers, where the computer department is engineering, right? User attributes and computer attributes can be used to create these conditional access rules. So if you've not played around with that, definitely something to look at, definitely something you could use to increase file system security in your environment. Okay, so Windows information protection. And then this is kind of the app protection policies for Windows. Builds a wall between corporate apps and data and personal apps and data. Right? So this is suitable for BYOD scenarios where people are using their own devices. We can prevent personal apps from accessing corporate data. We can prevent corporate apps from saving data to personal locations. Now, if you want to use this, you've got to have a subscription to Azure AD Premium. You've got to pay Microsoft some money. And it works best with apps that know about it, right? So the apps support some mobile application management capability or functionality. It can be used sometimes with unenlightened apps that don't know about MAM capabilities, but it doesn't always work. This applies to devices rather than documents. So WIP is the acronym here. Now, it permits also selective wipes. So one of the challenges we have with the BYOD scenario is somebody loses their device. There's some corporate data on there. There's some personal data on there. Well, I don't necessarily want to wipe the personal data because maybe somebody finds their device a week from now, and I don't necessarily want to wipe all their personal photos that may be very precious to them. So with WIP, we can do a selective wipe for a lost or stolen device and just wipe the corporate data. We can also use WIP to enforce the encryption of corporate data on the local device. So we can say, yeah, it's fine. You can use this app and you can use corporate data on your device, but it's got to be using encryption. And in response to the question that came up a few minutes ago in the chat room, the Q&A widget, data leakage protection, DLP. WIP can help with that. So DLP, kind of a broad term, but one of the things it does is allows me to say, hey, certain information is kind of sensitive, credit card numbers, social security numbers, PII is kind of the acronym, personal identifiable information. So we can set up some DLP rules in WIP that say, hey, if you're sending an email and it's got a social security number in it, we're going to flag the author of the email and say, hey, are you sure you want to send this? Looks like this has got a social security number in there or a credit card number. Or we can just block it. We can just say, no, we're not going to send it. So we do have some DLP capabilities that we can implement with WIP. Okay, two more topics in this little discussion, and then maybe we'll get a start on communications. Will we get a start on communications? Maybe not. We're going to get everything done. Don't worry. We'll make it through everything. DRM, I should mention here, also for data in situ. The cool thing about DRM, and you're familiar with this whether you know that acronym or not, right? If you've used, online music services or online video services over the years, you've probably encountered DRM, where you can only have a song on a certain number of devices, right? So it protects files wherever they are. So unlike NTFS permissions and conditional access rules, DRM permission travels with the document. DRM applies to documents, not devices. Now, how does it do that? Well, it's based on certificates. Uses a PKI. And so, as you can see the bullets at the bottom. So what we do is we set this up with AD CS, AD RMS are the services on premises that we could set up. And then we could say, all right, for these particular documents, they're very sensitive. We want to send them to some of our employees, but we want to make sure that they cannot save them under a different name or make sure they cannot print this document. So that's the kind of thing we can do with digital rights management. So it uses encryption and it uses certificates as a way of enforcing these restrictions Whether the documents stay on the LAN or maybe they get emailed to somebody outside of the network, doesn't matter, right? The protection, because the certificates are available by the public internet, we can verify the certificates, and the encryption is going to be keyed off of that, the right certificates being in the right places. Now, if you want to do collaboration with other organizations, you're working with contractors or suppliers, then you're going to have to set up some appropriate trust relationships between your Active Directory environments, for example, using Active Directory Federation services. But the important thing to remember about DRM is that it travels with the document. So now the new name for this is Azure Information Protection, or AIP. It is cloud-based. If you're using Azure AD for authentication, then this is easier to set up. You don't have to build an on-premises public key infrastructure and certificate authorities. So with AIP, easier to set up. And it can protect Azure storage. If you want to use the cloud-based Azure AD RMS, right, what we used to call it that, now AIP, sorry for all the acronyms, it gets a little complicated if you're also using the on-premises Active Directory rights management services. That gets a bit involved. We won't go there. But just kind of understand that you better buy some Tylenol, or you're going to have some headaches. You can do it, but it's complex. Right. Now, last topic here, before we take our next break, we're going to talk about Azure storage. So this is something that a lot of organizations are using as a way of dipping their toe into the Azure pool. Organizations that are really hesitant about cloud-based IT administration, but they maybe we can start playing around with the cloud a little bit. Azure storage is one of the ways that they start. So you can get some cloud-based storage, you can set it up, and then obviously it's available everywhere. You don't have to worry about replication. Microsoft's going to handle that for us. We can access it from anywhere. We can use Azure as a way of backing up our on-premises servers through Azure Backup. We can use it as a way of providing file shares to people in on-premises networks through Azure file shares that we can set up that support the SMB protocol, server message block, which is the file sharing protocol in Windows. So anyway, this is the way that a lot of organizations are sort of starting before they even get into cloud-based compute resources or cloud-based virtual networks. They might start with Azure storage. Well, when you set up Azure storage, we obviously are going to be very concerned about securing it. And this has been a big hesitancy factor for a lot of organizations. So we can set up network access restrictions for the storage that we create in Azure. We can set that up by protocol. We can insist, for example, that HTTPS be used and that we're not going to allow access via just HTTP. We can restrict access by range of IP addresses. So if we want to say this Azure storage is only available from certain IPs that represent bona fide networks of our company. And we can also restrict access by users. So there's two ways of providing access to Azure-based storage: access keys and shared access signatures. Kind of the important thing to remember here is that you normally don't want to give out access keys because they grant full access to the Azure storage. We have, at any one time, there are 2 access keys for key rolling, so we can update one key and still have folks have access via the other key while one is being updated. But when you give somebody an access key to Azure storage, they can do anything they want with all the data in that storage account. And a storage account might be associated with a lot of data. It might be associated with file shares, might be associated with backups. And so normally what we want to do with Azure storage is we want to provide more limited access to individual employees, maybe even contractors, suppliers, vendors, and so forth. But we would do that typically with something called an SAS. And that's a shared access signature. And so that is basically a URI, digitally signed URI, that provides secure delegated access to resources. So we're going to create that using the command line interface of Azure, or we can use a tool in Azure called the Storage Explorer. Anyway, we have the tools to build it. So we create this URI. And the cool thing is that we can slap an expiration date on there. We can say, yes, I'm going to give you access to this particular Azure storage account, but only for a month or only for 6 months or whatever. So you put an expiration date on it. And we can control some permissions. So we say, hey, you got access for 2 months, but it's only read-only access, right? Or if you need it, we can provide, write and delete capabilities as well. So this is implemented via a query string parameter that basically appends to the URI of the Azure storage blob. And so one thing to take away here is the key thing to remember for Azure storage, we're going to use SAS as a way of providing access rather than the access keys. But this is a really good thing to explore. And in fact, Azure storage can increase storage security in the sense that it makes it pretty easy to have offsite backups, right? So in terms of disaster recovery, I told you we weren't going to get into detailed disaster recovery in this course. We're not. But it's pretty cool in that if you have, a natural disaster, flood, fire, earthquake, whatever, and it wipes out a whole facility, then if you've been doing backups to Azure storage, then your recovery is relatively easy. And Microsoft will manage the infrastructure. And you can buy that Azure storage with different degrees of replication redundancy, right? So how much do you want to protect? Do you want to protect against a local situation, geographical? Maybe you can have replication of your Azure storage that's hundreds of miles away. Well, you can set that up, pay a little bit more for that, but you decide what level of protection you want. And with the appropriate precautions using SAS instead of access keys, for example, you can set this up. You can build these file shares in the cloud that support access by clients. You can even set up the file shares in Azure so that you can use local servers, on-premises servers, as caching servers for speed, for performance, but the primary storage is in Azure. Again, a nice way to sort of dip your toe into the Azure waters for organizations that have been hesitant to dive into cloud computing. Right. Okay, very lovely. So our next topic is going to be on communications. So that's a shorter discussion, data in transit. So in our last third of our session here, we're going to talk about data in transit. We're going to talk about anti-malware are the big topics. And then we have a quickie topic on auditing that's very light. We won't cover too much there. So mainly communications, encryption, data in motion, and then anti-malware security with the tools from Microsoft that'll help us with that. All right, we're going to be talking now about data in motion, information in motion, protecting communications. And then we'll get into our discussion of anti-malware, and then a few comments on auditing, and that should bring us around to the top of the hour here. So let's get into it. So start with a question, kind of curious about what types of network communications are encrypted in your networks. So are you encrypting all client-to-server communications? Are you encrypting client-to-server VPN connections? Hopefully, yes, would be the answer there. Are you doing selected local systems in terms of encryption of client-to-server communications between certain clients and certain servers? Or are you doing, let's see, and the fourth one, I'm not sure really why that fourth one is there. That's different. So just, it's the same as the first one. So client to server, all local systems. So just the top three, because the fourth one is duplicative of the top one. We'll fix that next go round. Sorry about that. But yeah, the top three, just kind of let me know if you, to the extent that you're aware, because typically network communications are not encrypted. And so we can do all the encryption that we want in terms of data in place, data in situ, with NTFS and EFS and BitLocker and all that good stuff, conditional access, DRM, all these kinds of things. But once we start talking about moving something or copying something over the wire, any local encryption, with the exception of DRM, but any local encryption with NTFS or EFS or BitLocker is going to be used to decrypt prior to moving or copying that data over the wire. So if I've got a network sniffer, I'm going to be able to see the content of that information. So we have to do something different. So everybody's pretty much doing VPN, good. In terms of client to server, just a very few of you, and that really doesn't surprise me. That's pretty typical. So that's about right. So just want to make you aware that we have the capability in Windows networks to protect communications between designated computers. Kind of interesting. So that's IPsec. And so we'll spend a little bit of time on that. Obviously, VPNs we want to protect. And we want to talk a little bit about Windows Firewall as well in terms of restricting the communications between specific systems. It's something that is in the Windows Firewall, but you might not know about it. Now, not all of you may use the Windows Firewall, but if you do, it's got that capability, creating what we refer to as kind of a little bit like virtual networks, where we can set up designated subsets of our computer population that are allowed to communicate with each other only in an encrypted fashion. And then we'll talk about network security groups, kind of a firewall capability in Azure. And we kind of already mentioned DLP, so we probably don't need to go over that again, but we'll just maybe fill in a couple of gaps on DLP here, because that, again, applies to communications in transit, right? Data in transit. So IPsec is one of the things that we're going to look at. So this is what I just said. Basically, if you're using EFS and BitLocker, data gets decrypted for transmission. Also, we want to block unwanted inbound communications. So very, very important. IPsec then gives us a bundle of capabilities. We can encrypt network traffic with IPsec. And, for some people, that's as far as they are aware of IPsec's capabilities. But beyond that, encryption, we can limit which computers can talk to which others. So we can restrict traffic to only certain members of the domain or specific servers, specific clients. So we got to have, if we want to do this in Windows, we got to have the Windows Firewall, because IPsec is implemented as something called connection security rules in the firewall console. So we can specify an IP range, an authentication method, and ports to restrict who can talk to whom with IPsec connection security rules. We can also set whether we want that authentication to be request versus require. Require, for example, with certificates. So that's kind of an important capability. And the reason we don't use it broadly is that it slows things down. So there's a pretty serious communications penalty with IPsec encryption. Now, it's less than it used to be, because we have the capability now with a lot of network cards to do an offload to the network card of some of the IPsec encryption, decryption chores. But Microsoft does not recommend that we use IPsec encryption for all network communications, because it's just going to slow things down too much. You can, but you're definitely going to take a performance hit if you do. So normally we'll use the Firewall with Advanced Security console, and we'll set up, we say, between these computers, we've got this group over here, maybe our design team is working on some cutting edge new stuff, a lot of intellectual property, proprietary information, and their communications with the file servers, we would like those to be encrypted. You could set that up with the Firewall console using IPsec connection security rules. So that's a capability that a lot of organizations underutilize, and so important that we're aware of that. Everybody thinks about encryption for VPNs because we're often traversing across the public internet. And so we have traditional VPN protocols, all of which give us some degree of encryption. There are some modern riffs on these VPNs. In the Microsoft world, we have direct access. We have always-on VPNs. These are kind of newer. Always-on is the newest. These are newer variations on the VPN theme. Lots of organizations don't use Microsoft for VPN software. They might use Cisco or whoever, lots of different vendors. But if you do use Microsoft, you might want to take a look at always-on VPNs, which are kind of cool. They're a little bit newer, a little bit more secure, a little bit more convenient for users. With VPNs, just a couple of quick comments. Authentication via password is possible. Authentication via certificate is generally more secure. So that's one area where you can improve security in your environment. For example, we could use an SSL certificate to support the SSTP VPN protocol. Now, if you have a lot of VPN, well, not a lot, let's say you have multiple VPN servers and you want to create some rules for who can authenticate, who can connect into the corporate network, when, under what circumstances. Again, those are good things to implement, but if you have multiple VPN servers, it might be a little bit laborious and tedious to set those rules up on each VPN server. So we can have a radius server, which is a central clearinghouse for the authentication rules. All your other VPN servers can look to that one radius server, stands for Remote Access Dial-In User Service. And we can use that as a way of just creating the rules in one place, so we don't have to worry about going around to each separate VPN server and creating those access rules individually. Now, we can have VPNs in Azure as well. So once you start building your virtual machines in Azure, we can set up an Azure VPN gateway. And that will basically be a gateway subnet. And Azure is going to build some virtual machines to manage that subnet. Each virtual network in Azure can have one VPN gateway. Now, that VPN gateway can connect at multiple points, for example, to on-premises networks. So typically, you're going to have an on-premises VPN device that has a public IP, and this should not be behind a NAT server. And that is typically going to be how you're going to set up communications between an Azure VNet and an on-premises LAN. It's not the only way to do it, however. There is a somewhat easier and a little bit more expensive way called ExpressRoute. So kind of be aware of that as well. ExpressRoute actually is more secure because it doesn't involve the public internet. It's also generally faster and more reliable. So ExpressRoute, you pay a little bit of money and you get a better connection between your on-premises LAN and any virtual networks that you might be building in Azure. We don't normally use the concept of VLANs for security. That's mainly for segmenting networks for performance reasons. So not as secure as separate physical switches. So I wouldn't want you to really look at VLANs if you use them as a way of adding significant security to your networks. The firewall, however, can. The Windows firewall is the same firewall on clients and servers. We have different profiles, so domain, public, and private. So if you have a portable Windows 10 device, let's say, we can have the firewall set up so that the domain profile has some fairly moderately relaxed rules, because if we're on the domain, then presumably we're inside the corporate network, which is well protected by DMZs and external firewalls. And we can also have a public profile that would be used when an employee is using Wi-Fi at a coffee house, for example. So Windows Firewall has built-in rules and rule groups, but we can build as many custom rules as we want. It's bidirectional, so we can have inbound rules, we can have outbound rules. We have to have this if we want to use IPsec. And remember the two things we can do with IPsec for securing communications: encryption, and then limiting which computers can talk to each other. We can also configure the Windows Firewall with group policy, which is very nice. And we can deploy that configuration so we don't have to worry about configuring individual systems. We can just deploy the settings via group policy on a site, domain, or organizational unit basis. So that's the Windows Firewall. Now, in the cloud, it's been around for many years. You've all probably played with it. But in the cloud, we have a similar capability, but it's got a different name. So we have the Azure concept of network security groups, or NSGs. And this is really a lot like what we would consider as a firewall setting or collection of firewall settings for on-premises networks. But it's the Azure mechanism for filtering traffic to and from your virtual networks with rules. So these rules can be made to apply to virtual networks in Azure or specific subnets of those virtual networks, or indeed we can even apply those rules to individual VMs. Don't normally do that, but you can. And the security rules in the network security groups are going to be comprised of source and destination address, source and destination port, and source and destination protocol. So those are the things we're going to specify. And then if we have multiple rules that might overlap or conflict, we can specify priorities for the individual rules. Now, there is something called the Azure Firewall, and I don't have a slide on it, but if you need to do traffic restrictions based on DNS names, based on host names, as opposed to IP addresses, then you would probably want to look at the Azure Firewall. But for most of the things that we need to do in terms of providing firewall-like traffic rules for our Azure virtual networks, it's the network security group that we're going to use for that purpose. So we talked about DLP already, so don't really need to go over this again. There's nothing new here, except one of the things that we can do in DLP is we can designate this next to last bullet here, designate safe parts of the network and or internet. So we can say, hey, here's the IP range for our different corporate subnets, our different branch offices, headquarters, et cetera. Those are considered safe in terms of DLP rules. But we already really talked about that, so we don't need to go over that again. So those are kind of some things to think about for data in transit, which is kind of a different set of concerns, right? Because, again, those in-place encryption methods aren't going to help us when data is moving around across our network and maybe outside of our network as well. All right, so 2 topics left. Anti-malware, kind of a big one. Lots of parts and pieces here for anti-malware. And then just a couple of quick comments on auditing. And I think that's going to be a pretty good overview. So I'm a little concerned about the time, so I'm going to skip over one of the questions here and just go to the overview of anti-malware. I want to make sure we get everything discussed by our time. The overview of anti-malware. Very confusing branding from Microsoft, but most of the products are now branded Microsoft Defender. You're still going to see references to Windows Defender because they haven't updated all of the sort of chunks of technology that they've painted with the Defender name. Some of the components here do require separate licensing, such as the advanced threat protection capabilities. Most of the Defender-related anti-malware pieces are going to get updated for clients and servers via Windows Update. And most of the components we're going to talk about here in this section that are oriented towards anti-malware purposes are going to be manageable and configurable with the usual methods, right? Group policy for on-premises or configuration manager for on-premises, and then in the cloud Intune or your MDM solution of choice, and as well PowerShell, right? We can manage a lot of these parts and pieces with PowerShell. We're not going to get into the PowerShell stuff. So here are the products that we're going to chat about. And so Microsoft Defender Antivirus is the antivirus tool. Defender Antivirus ATP, Windows Defender System Guard, Application Guard, not the same as Application Control, and Smart Screen, which you might know about from using browsers, and then Exploit Guard. And then we'll end this section with a quick refresher on user account control, which you're probably already familiar with, but very important as well in terms of its anti-malware utility. So let's start with the product that most of you have seen before, Microsoft Defender Antivirus, formerly known as Windows Defender Antivirus, formerly known as just Windows Defender. So of all the antivirus tools that are out there, this is considered a good one. It is relatively light impact on operating system operations, which you would kind of expect because Microsoft knows their own operating systems, right? It uses both predetermined signatures to deterministically identify malware and also heuristics. So when you see that word, it's just a fancy term meaning educated guess, right? So heuristics is basically, this looks kind of like stuff we've seen in the past that have turned out to be malware. Flexible configuration, so we can do full scans, we can do quick scans, custom scans, and in more recent builds of Windows 10, for example, we have the ability to do offline scans, which are more thorough. Defender Antivirus can do real-time scans or periodic scans or both. We can do exclusions as appropriate, for example, to improve performance. Maybe we don't want to scan zip files or DLL files or what have you. And then we can configure how Defender Antivirus will send data back to the mothership, right? Sample submission for discovered malware. We may or may not want to participate in that communication back to Microsoft, because we may not necessarily want Microsoft to know what we're doing. But if we want to do that, we can opt in. So all configurable via group policy and or MDM. When to check for updates, how often to do scans, what type of scans we do, what do we do in terms of when we find potential malware in terms of quarantine, what options are we going to provide through the user interface to end users. Those have shrunk over the years. There's relatively little that users can configure these days on a Windows 10 machine or Windows 11 machine when it comes to the Defender antivirus capability. You can't even turn it off completely unless you install another antivirus tool. So there's Defender ATP, Advanced Threat Protection, a separate paid service that might be bundled with other services. So this takes you kind of a step further, and it uses sort of big data type analysis, cloud-based analysis. There is some configuration to do on the clients. You're going to have to onboard the clients. There's a wizard for that purpose. It's got to have the Windows 10 diagnostics telemetry settings turned on. But what this does, and Microsoft kind of sells this on the basis of, hey, you know, we've got the ability to do cloud-based analysis based on lots of intelligence that we get from our various customers and vendors across the world. And we can then provide alerts to you based on patterns, behavior patterns, based on heuristics. And so just kind of a heavier analytical capability than we get with the local Defender antivirus product. But this is basically cloud-based analysis. All right. So Windows Defender System Guard. This is a new name, but it's an old capability. The requirement of signed device drivers is an example. So System Guard leverages that code integrity service that you remember we talked about back in the context of Windows Defender Application Control, where we build that list of applications that we're going to allow people to run on our standard corporate systems. So that's all System Guard is. If you have UEFI secure boot, that's part of it. But the code integrity service is basically validating device driver code every time a device driver loads to make sure that it is signed, and that is System Guard. So you already have it. You've actually had it for years, but that's what it's called. Nothing to configure here typically. So Application Guard is a different animal, and it's also different from Microsoft's Defender Application Control. I'll tell you, whoever's in charge of naming this stuff at Microsoft, I would just like to fire them and then rehire them and fire them again. It's just their terminology is so doggone confusing, but we just have to work with it and deal with it. So Application Guard, Defender Application Guard, is basically trusted websites. So we get to specify which websites we trust. Right? We know that these are safe. Non-trusted websites then would open up in a VBS. Here's another surfacing of that VBS concept, in a VBS container with extra isolation, right? So we don't know that it's a safe website, so we're going to fire up the browser in a what is basically a variation on the theme of a Hyper-V virtual machine, the VBS container, and the usual VBS prerequisites are going to apply here. So 64-bit version of Windows, second level address translation, and the hardware-assisted virtualization capabilities. So there's two modes of this. There's a standalone mode and a managed mode. The managed mode allows us to centrally create a list of trusted websites that then we can deploy to individual clients. So look, if you're, it just depends. Are you going to use this? Is this going to be useful to you? It just kind of depends on whether you have a lot of problems with employees visiting sites that turn out to be having malware associated with them, then you have infections and so forth. So if that's an issue, then you might want to look at this. This has not been really all that publicized. So there are a lot of organizations that really don't know all that much about Application Guard, Defender Application. So it's something that you really should take a look at, be aware of. It does give you somewhat additional degree of comfort. It's a little bit analogous to the Windows sandbox that we talked about, except that the sandbox is really for the operating system, and Application Guard is really kind of a special purpose VBS container for your browser. Right. So that's what that is. All right. So now in our continuing march of Microsoft Defender stuff, here is Microsoft Defender Smart Screen. So this is a reputation filtering system. Now, you probably have heard the term Smart Screen because it's been around for years. It was actually even around in the Internet Explorer days, right, before we got Edge and then the new Edge, right? So you can see the Smart Screen settings. They've broadened, right? Microsoft has broadened this capability in recent years. So initially, when it was part of Internet Explorer, it was just something that IE would use to warn you. It would basically check with a Microsoft database, right? Check with the mothership. Whenever a user would go specify a new website on the public internet, Smart Screen would check to make sure that that website wasn't on Microsoft's list of naughty internet sites that do evil things like phishing attacks and try to steal credentials and so forth. So it's basically a reputation engine. Now, back in the day, some folks would turn off Smart Screen because it would sometimes raise false alarms. And so users would get concerned. They'd go to visit a legitimate site, but it would meet some Smart Screen criteria that would cause Microsoft to raise a flag. And so some folks sort of got turned off with it. Microsoft has improved their reputation filtering system over the years. It's really targeted towards phishing sites. It's still not infallible, so you can still get false positives. But it has gotten better, and it's gotten better to the extent that Microsoft has now extended the capability beyond just websites, but also to store apps, Microsoft Store apps and files. And if you want, you can extend it even further to all apps using something called Exploit Guard, which is next. Right. Now, Exploit Guard is something that requires 2 slides to talk about because there's lots of different pieces to it. If any of you had any experience back in the day with something called the EMET, the Enhanced Mitigation Experience Toolkit, this was something that Microsoft made available in years gone by. And it had lots of different parts and pieces, and those have been sort of migrated over to this umbrella designation of Microsoft Defender Exploit Guard nowadays. So what is this all about? Well, first of all, it requires that you be using the Microsoft Defender antivirus. So if you're using some other third-party antivirus, then you're not going to be able to take advantage of Exploit Guard. So some of these things are a little bit abstract and a bit more arcane. We won't get into them in super detail. Attack surface reduction, however, is one that's pretty easy to understand. This will block threats in the form of macros. So with Microsoft Office, we have the ability to create macros. Sometimes those can be created by hackers, and they can have malware effect. And so ASR in Exploit Guard is designed to block those kinds of script-based and macro-based threats if you're using Microsoft Office applications. Now, there's something called controlled folder access, which is kind of interesting. Controlled folder access is kind of a response to the ongoing wave of ransomware attacks. Matter of fact, gosh, just yesterday or day before yesterday, I saw another headline about a big ransomware attack. So ransomware is ramping up. We're seeing more and more of these attacks. What controlled folder access does, it's a part of Exploit Guard, and it provides protection for user profile folders. Now, you may or may not be using user profile folders in your environment, but they've been around for years. Some users still store documents. It's still the default save location for some users. Organizations have kind of tended to get away from storing documents in the user profile and use folder redirection, for example, or other techniques, file servers. But we can actually add folders if we want. So while controlled folder access by default protects user profile folders, we can add other folders if desired. And then what we can do is specify which apps are allowed to write to these protected locations, the user profile folders and other designated folders that we want to protect. So the way this helps thwart ransomware is that with controlled folder access, we're basically saying, hey, if you're not on the list of safe apps, we're not going to let you write or encrypt, right, which is what ransomware does, some of these folders on the local system that we want to protect. Okay, so phishing and spam, a question comes in, phishing and spam are more sophisticated nowadays, so for filtering these out, well, yeah, again, so for phishing, you could look at the smart screen and extending smart screen using exploit guard. You could look at using the protected website list that we just talked about. So yeah, some of these things that we're talking about here can definitely help with phishing. I will tell you, just as a side comment, we can have all the cool technology in the world. The best thing, in my experience, to thwart phishing attacks is user education. So let's help our users understand what phishing sites look like, the various different types of phishing attacks. So if we go into great detail on that in some of the O'Reilly content for the Security Plus and A+ certifications, and other sources like Pluralsight have great references and resources on that as well. But basically what we want to do is have a pretty good campaign of user education so we can say, hey, here's what phishing looks like. Here's vishing, right? Voice-based phishing, spear phishing, whaling, all these terms. Help people understand what that looks like and the different social engineering techniques that people will use. And that's going to be ultimately, I think, more effective than any one of these technology solutions. But Exploit Guard can help, Application Guard can help, certainly, and Smart Screen. These are some of the things Microsoft gives us that can help out. Now, more stuff on Exploit Guard. So, and this is the way we can extend that Smart Screen reputation filtering concept to third-party applications. That's called network protection in the Exploit Guard umbrella of capabilities. And then we also have a collection of things that are really esoteric called exploit protection. And these are capabilities that largely focus on managing memory. So we have, for example, memory restrictions, data flow restrictions to frustrate certain types of malware attacks. Control Flow Guard, you may have seen some of these things. Data Execution Prevention, DEP, and ASLR is a technique for mixing it up so that certain code and data areas are stored in different addresses instead of at the same place all the time. So to the extent that programs and data always use the same locations in memory, that makes them more hackable, more attackable, right? So with address space layout randomization, we are going to address that by saying, hey, to the extent that we can, we're going to put code segments, we're going to put data segments in different places in memory to make them harder to hack and attack. So these four aspects of exploit protection are basically designed to deal with code and memory in network, in RAM, and where those locations are and how they're protected and what parts of memory can talk to which other parts of memory. Won't go into those in any detail, but just watch out. I'll just make one comment here and say that if you are implementing some of these capabilities, be aware that they can create problems with specific applications. So to the extent that you want to implement these, great, do it. But just be aware that you really ought to test your applications to make sure. And that goes, if I can go back a slide too, that also goes for controlled folder access. I found for some applications, they get indigestion if I turn on controlled folder access. So you just have to do some application testing with these features. And then sometimes there are mitigations, sometimes there aren't. Right. Now, one of the things that has been around for a long time and that sometimes organizations turn off, and that's usually not a good idea. User account control has been in Windows for a long time, And you've seen it. You get prompted when you want to try to do something administrative. So even if you log in as an administrator, user account control is going to say, right, okay, I'm going to give you a limited security token for your day-to-day things. If you want to do something administrative, then I'm going to ask you if you want to elevate your security token for an administrative task of some kind. And the idea here is to reduce the consequences of accidentally running across some malware. So let's say we've implemented Microsoft Defender Application Guard, and we've got a list of safe websites, and we're using Smart Screen, and we're doing all those things. But we still have situations where occasionally I might log in with an administrative account. I might go to a website and encounter some malware. Well, what user account control does is it prevents me from using my high security token when I'm doing just some internet research or using a browser. That doesn't need the high security token. And in fact, when I run across some malware, even though I logged in as an administrator, if I'm operating with my low security token, the malware that I encounter is going to execute in the security context of a standard or limited user. And that means that that malware is not going to have the same range of places it can go in terms of the local system or the network to try to infect my system and connected systems. So it might not stop the malware, but it can certainly slow it down. And so that's the idea. Back in the days, if we go back to pre-Vista, to Windows XP, we didn't have this. And so in Windows XP, when you'd log in as an administrator, everything that you did was using your high administrative token. And that means if you ran across malware by accident, it would run in an administrative security context, and it could do more damage. So that's why user account control is so important. Now, initially, people hated it in Vista because it was so annoying. It would just nag you. Every time you turned around, you get a UAC prompt. Are you sure you want to do this? Or do you want me to elevate your security token now? Looks like you're about to do X, Y, Z. So they moderated that a little bit. And in recent versions of Windows, including Windows 10, we don't get prompted, the default behavior at least, is that we don't get prompted if we're just running Windows control panels, the settings applet, and so forth. If we're doing Windows administration, kind of day-to-day Windows administration, then it's not going to prompt us to verify that, in fact, we want to do this and elevate our security token. So this is all configurable via group policy. We can turn it off, again, not recommended. We can limit the alerts. We can set the prompting behavior for administrators and non-administrators. So these are things that we can do. So the typical behavior is for administrators to be prompted for consent, and non-administrators will be prompted for credentials. So if I log in with a standard account and I try to do something administrative, I try to run a control panel that has a shield icon by it, for example, then I'm going to be prompted for credentials. Please provide the credentials of an account that has administrative rights on the machine. You might want to change that, right? So, I've talked to IT administrators, desktop administrators who will just say, no, I want to change that behavior. If a standard user wants to try to do something administrative, I just want to do a flat-out denial. And that might even be more secure. So you could fine-tune these user account control settings and maybe even improve security beyond what we have out of the box. But it's a lot less annoying than it used to be, and it's really kind of a brilliant design. It doesn't guarantee that we will never encounter malware, but it does help reduce the power and the permissions and the privilege that malware might have if we do accidentally encounter it. Right. Okay. Very lovely. How are we doing on time? We're doing great. Quarter till. So that is just the right amount of time to chat briefly about auditing. And then I think that's going to be a pretty decent 3 hours. Wow. Everybody holding up okay? In terms of words per minute, it's like I told you, it's kind of like drinking from a fire hose. A lot of you probably have already been aware of some of these things, but maybe there have been a few gaps, the things that you weren't aware of, or maybe some things that you hadn't looked at in a while, and things that you might want to do some additional research. And sometimes that's the best benefit of a session like this. So let's get into auditing. So auditing in AD and Azure AD, just a few comments here. It does not prevent unauthorized access, but it helps us analyze and understand potential or actual unauthorized access. So what happens so we can take preventive measures. And in fact, in some cases, it might be required by law or regulation, depending on the industries that we're operating in, or required by our management. So the basic methodology of auditing in Active Directory is we turn the feature on via group policy or perhaps MDM. We'll get to Azure AD configuration in a moment. We're going to specify what we want to audit, successes or failures or both. Now, for example, if we're interested in doing some security auditing to look at potential intrusions where we think people are trying to break into our network, but we think it's an outside job, then we might want to look at failures, right? So when people are trying different passwords, for example, well, we're going to get a lot of failures in a brute force type attack. Now, if we think it might be an inside job, we suspect that we might have some employees that are trying to gain unauthorized access, then we don't want to necessarily just look at failures because they might actually have some credentials. So we could look at success in that case, or both. And then the third step is if we're auditing object access, right? So access to file shares, for example. So there might be some specific sensitive file shares that we want to audit access to. We could set the specific information on those shares and say, here's what we want to audit. Attempts to read, attempts to write, attempts to delete, and so forth. And maybe limit that by specific groups. So all of these auditing events that Windows and Windows servers and clients can generate will go to the security event log for the relevant system. Now, we can restrict auditing to particular users or particular groups to kind of cut down on the volume of this information with a special kind of access control list. It's called a SACL, System Access Control List. It's similar to the discretionary access control list that we set up, for example, with NTFS permissions. But the system ACL is designed specifically for purposes of auditing, not for restricting access as we use with the discretionary ACLs. Now, we want to make sure that when we do auditing in Active Directory that we scope those GPOs to the appropriate organizational units. For example, a lot of you in our group today are doing logon auditing. Well, if we want to audit account logons, we want to scope that in our GPO to the default domain controllers organizational unit, because domain controllers are where people actually log on, right? So again, we want to avoid the scenario where we've got just a giant avalanche of information, just way too much stuff to analyze. So there's basic and there's advanced. The basic auditing in AD is the older kind. You generally don't want to use it anymore. It's still there, just a quick note. We certainly don't want to use both types in the same group policy object. So the types of things that we can audit in AD, well, there's file share access, anywhere in the file system. The registry, we can actually audit registry accesses, and the security accounts manager where we store local credentials. Privilege use, account logon. A quick comment about account logon, that's a little different from plain logon events. That's a sort of bit of a subtle distinction. So account logon is when you're logging on to a domain account, for example. A plain logon, a non-account logon event might be when you are connecting to a file share and you're authenticating to a file server. That's considered a logon event, but not an account logon event, okay? Directory service access for domain controllers, policy changes for changes in access control. These are all things that we can audit. So a few tips for you in terms of auditing in Active Directory. If you decide to increase auditing, for example, in response to a particular security breach, don't forget about it. The more auditing you do, the more performance impact it can have, right? So excessive auditing will impact performance. So if you're going overboard on the auditing, doing more than you need, or if you're doing a lot of auditing for something that happened 2 years ago, then you're impacting performance when you don't really need to. You might also consider, in particular with Windows auditing, there are extra tools that you can use that will give you analytical capabilities. The security log can be daunting if you don't have some extra intelligence in the form of analytic software tools. Microsoft provides System Center Operations Manager, and it has some tools that will help us understand and evaluate the auditing logs. So that can be useful. There's lots of third-party products as well that we can use for that purpose. So in auditing in particular, third-party tools are, and indeed extra tools from Microsoft like Operations Manager can be very helpful. And it's just such a huge volume of information that we need some intelligence in order to help us zero in on some trends that might be concerning.